Start then. Welcome everyone to ISTQB training CTFL session number 14. Let's first of all see what we did in last session. So in last session, we continued with black box testing techniques and we covered decision table testing, state transition, and use case testing. And with that, we completed black box testing. Earlier, when we started this module of test techniques, we read that test techniques are broadly classified as black box, white box, and experience-based testing. So we are done with black box, and today we will be covering white box testing and experience-based testing. Okay, let's first of all go through what is white box test technique. Earlier in one of our session, we did briefly touched the definition of white box testing, and then we said that in later on we will do it in detail. So today we'll be covering it in detail. So white box testing is also called structural or structure-based technique. So this is a question which commonly it comes in the exam where it's asked that which test technique is also known as structural technique or structure-based technique. So this is something to remember, that black box testing, because it's more involved with the behavior of the system, so it's known as behavioral test technique, while white box is more associated with the structure. So this is something you should remember. So white box testing is based on analysis of the architecture, detailed design, internal structure, or code. So in black box, we were just concerned about the inputs and outputs, and we didn't know what's happening in between the system. But over here in white box, we are testing the internal structure of the system, and it can be anything. It can be the architecture, it can be code, or anything else, with whatever gives us the detail of the internal of the system. It is also applicable to both functional and non-functional testing, and it concentrates on the structure and processing within the test object. Test conditions, test cases, and test data are derived from a test basis. So in black box also, we said that they are derived from test basis, but with each type of different test technique, the test basis will be different. In black box testing, test basis was different. That was more around the requirements of maybe the requirements of the system. But over here, the test basis will be either code, software architecture, detailed design, or any other source of information regarding the structure of the software. So coverage is measured based on the items tested within a selected structure, for example, code or interfaces, and the technique applied to the test basis. So regarding coverage, when we will go further in detail of white box testing types, then we will individually see that how to measure the coverage using that specific test technique. Okay, so now we are covering what are the types of white box testing technique. So statement testing and coverage is one type of the first one, which we will cover under white box. So let's first go through the definition, and then we will understand the logic that how does that work. So statement testing is a white box testing technique in which test cases are designed to execute statements. And statement coverage, of course, it's related to statement testing. So it is the coverage of executable statements. So over here, if you see, one term is used as executable statements. So this is something to remember. Statement testing only covers the statements in a code which are executable. So there are two kinds of statements: executable statements and non-executable statements. Non-executable statements would be something, any line of code with which there is no action. Like if we are going through the code and we are declaring a variable, so we are just declaring it. There is no action associated with it. So that will be, so statement testing covers only the executable statement. So when we will go through the example, then it will be more clear. Statement testing, it checks the number of statements in the source code which have been executed. So it's a type of white box testing, and what it helps with is to understand that is the code behaving in the right way, as it's supposed to do, and it's doing what it's supposed to do, and it's covering all these statements to ensure the testing maximum test coverage. In order to calculate it, it's calculated in terms of percentage, and this is the formula: number of statements executed by the test divided by total number of executable statements in the test object, and as it's a percentage, so we have to multiply the answer with 100 to get the percentage. So this is the formula we use for measuring the coverage of statement testing. Okay, let's see an example now. This is a pseudocode. So pseudocode is, if you don't know, it's a code but written in simple English, which everyone can understand, rather than a specific syntax of a programming language. So this says read A. Read A means like we are taking the input from the user. So it might be a system, a field where we are taking the input. So read A is a variable. If A is greater than 5, print A is greater than 5. And if print, this is the end of the program. Okay, so we have an if statement over here. If any one of you is not familiar with the if statement, it's usually used when we have few conditions, few decisions, like if A is greater than 5, then do this, else do this. And this is the kind of syntax we use usually in different programming languages, slightly different for each one, but this is the main core, the way we define the if command. Right, so over here, what it says that first of all, we are taking an input and we are checking if that input is greater than 5. If it is greater than 5, then print this. And of course, if A is not greater than 5, then it will bypass this statement and it will go to end if. End if is that where the if statement is ending. So we have to mention this as well. Then it's printing, this is the end of the program. So over here, what are the minimum number of test cases required to achieve 100% statement coverage? So what do you think? I will let you take a guess, and then we can see that if that's correct or not. So remember that we are talking about the executable statements. So first of all, go through these lines of code and think that, yes, when you are running these statements, how many of them are executable? So let me know your answers in Q&A section. Okay, Jatin has said test case one number of test case. Anyone else? Okay, Madhuri has also said 1 if statement is executable. Okay, so yeah, Jatin and Madhuri, both of you are correct. We require at least one test case, and with one test case, we can achieve the 100% statement coverage in terms of this example. Let's see how. Okay, so now the same one I have represented in a flow diagram because it would be easier to understand the flow. I would suggest that whenever you have a question in the exam, usually the questions will come in this form, and it will be easier for you if you draw it in a flow diagram, because it will be easier to navigate through all the conditions and all the statements, and the coverage can be easily estimated. Okay, so it's the same line, same code, but I have written in a flow diagram. So let's go through it. Read A. First of all, it's reading that taking the input of A, and then checking if A is greater than 5. Then if the statement is true, then A is greater than 5, and actually after that, it's also printing this is the end of the program. So it's not, okay, so in statement testing, we don't cover the false statements. It only covers the executable statements, the true conditions, because the purpose of statement testing is that whatever the code is written, to check whether it's working or not. It doesn't care about the false conditions, like when we are testing the negative test cases. No, it will only cover the conditions which are given. Yes, if the negative conditions are given as part of the code, then yes, it will cover. Like for example, let's go back to this code. Over here, usually if you have worked with if statements, you remember that we usually have the structure like if, else, if, then end if, right? Over here, we don't have any else statement. It would have been like if A is greater than 5, then print this, else print this. Then we would have another scenario, but over here, it's not like that. It's printing this. If A is greater, then it's printing this, and it's printing this regardless of whether A is greater than 5 or not, right? So we need only one test case, and with that test case, we can check the all flow of the executable statements. So this means that one test case is required to cover the statements, which means 100% coverage. So I hope that this concept is clear, because if this is not clear, then the next one which we are going to study will be confusing as well. So in statement testing, just remember that we are going through all the executable statements in the code where the conditions are true. We are just checking the true conditions as per the code, right? Okay, so now the next type of testing is decision testing and coverage. We covered statement testing. Now the second one is decision testing and coverage. So in decision testing, what it is, it's a white box test technique in which test cases are designed to execute decision outcomes. And the decision coverage is the coverage of decision outcomes. Okay, what are decision outcomes? I'll take you back to this one. So this usually in the flow diagrams, wherever there is this diamond kind of notation which we use, this is for either conditions or decision. So remember that decision and the term conditions are the same, that we have a condition or we have a decision to make, and there will be multiple decisions over here. One can be true, the other can be false. So this is known as either a condition or a decision. So in statement testing, we were covering all the executable statements for true conditions, but in decision testing, we are covering all the decision outcomes, regardless it's true or false, which means that we will be testing both true and false outcomes. Okay, so as we are done with the definition, now let's understand it in terms of the same example which we did for statement testing. Before that, let's just go through the formula as well. So every decision for both true and false are executed. So this is something which we already covered, that yes, both true and false outcomes are tested. And the coverage is measured in terms of percentage. And the formula is the number of decision outcomes executed by the test divided by the total number of decision outcomes in the test object. Okay, so going back to the same example, now it's asking what are the number of test cases required to achieve 100% decision coverage. So earlier we did 100% statement coverage, and now we will do 100% decision coverage. So can you please try to do this and let me know what do you think would be the answer? Okay, we have got one answer, and Vineet has given us the answer, and he is saying that there will be 2 test cases. Okay, any more? Any more answers? Okay, Jatin is also saying 2. One is for true and second one is false. All right, yes. Okay, let's now see. So yes, Jatin and Vineet, both of your answers are correct. Let's see how. So we already covered the true one in the statement coverage. So one test case covered all statements, but only one decision outcome for true, which means if we take that one test case, which we did for statement testing, in that case, statement coverage was 100%, but decision coverage will be only 50% because we are covering only one decision outcome. So this orange one is representing the one which we covered for statement as well, and for decision as well, the true statement will be covered. And now the blue one, this one, the false one, which we ignored in statement testing because it's not required in that. To cover false decision outcome, one more test case is required, which will increase decision coverage to 100%. Okay, so I hope that this is clear that what's the difference between statement coverage and decision coverage, and how these both are not the same and what's the difference. Okay, now let's just go through the value of statement and decision testing so that it's much clear that in which circumstances we should be using either of them. So when 100% statement coverage is achieved, it ensures that all executable statements in the code have been tested at least once, but it does not ensure that all decision logic has been tested. So we have already seen this in the example that 100% statement coverage doesn't mean 100% decision coverage. Statement testing may provide less coverage than decision testing. Yes, because the purpose of statement testing is totally different than the decision testing. When 100% decision coverage is achieved, it executes all decision outcomes, which includes testing the true outcome and also the false outcome. And the last one is achieving 100% decision coverage guarantees 100% statement coverage, but not vice versa. So if we have 100% decision coverage, we can claim that it has also covered 100% of statement coverage. But we can't do the other way around. We can't say that 100% statement coverage also guarantees 100% decision coverage. No, that's not correct. So I hope that this difference is quite clear, that decision coverage, it measures the coverage of decisions or conditions in the code, and that includes both true and false, while statement coverage, it measures statement coverage, the number of statements in the code which have been executed. So is there any question around statement and decision testing? Okay, there is no question, so we can progress further. So that was all for white box testing, which you need to know in terms of the syllabus of ISTQB, statement testing and decision testing, right? Now we come to experience-based test technique. So what is experience-based? These kind of techniques are usually used when we are low in resources or we have less time, so we have some time constraints. So based on that, if we have an experienced resource, then we make use of that and we use experience-based test technique rather than more formal test technique, which is black box or white box. So over here, we leverage the experience of developers, testers, and users to design, implement, and execute the tests. So when we are talking about experience-based test technique, it doesn't only confined only for to the tester or the developer. It can be anyone in the project team, because when we are talking about a project, it includes the entire team. So maybe there is a project manager who has done a similar project before and can share his or her experience that, oh yes, we have these issues in the last project. So maybe these would be the areas where we should focus more on testing, etc. And maybe a business analyst who had covered a similar kind of system before and can share that what kind of issues were there in the requirements, etc. So it can be anyone who anyone can take part in this kind of testing and can share their experiences. This is often combined with black box and white box test techniques. So experience-based test technique can be used either on its own, in, if, as I discussed, that if we have budget constraint or time constraints, but it can also be topped up with the formal test techniques like white box test technique or black box, because yes, maybe we have a proper time scale to work on it. We are doing either black box testing or white box testing, but still, if we have someone experienced in the team who have prior experience, it's always good to top it up with any other test technique. Yeah. So maybe we in black box testing, we have a certain number of test cases, but maybe a developer can say that, oh, have you covered this specific test case? Because last time I remember that we had issues in this area. So maybe you should focus more, or maybe you should design the test cases based on this criteria, etc. So that will always help. Talking about some common characteristics, test conditions, test cases, and test data are derived from a test basis. For example, knowledge and experience of testers, developers, users, and other stakeholders. So if we see this now, we have seen this statement for black box, white box, and now experience-based as well. And in all these three cases, the test bases are different. So in black box, it was more oriented towards the requirements, specifications. In white box testing, it was the internal structure or code, or architecture. Over here, the test basis is knowledge and experience of testers, developers, users, and other stakeholders. So anyone who's working in that team, whatever prior experience they have in that domain, in that system, they can share that, and that can be served as the test basis. Based on that, which the test conditions, test cases, and test data are derived. Okay, so now we'll go through the types of experience-based test techniques. Okay, so the first one is error guessing. So what is error guessing? Error guessing is a technique used to anticipate the occurrence of errors, defects, and failures based on the tester's knowledge, including how the application has worked in the past, what kind of errors tend to be made, failures that have occurred in other applications. So all these techniques, as they are part of experience-based test techniques, so we know that whatever we are talking about, it is based on the prior knowledge or experience of anyone who is part of that project, who has worked on a similar system or domain. So so they can be error guessing can be based on how the application has worked in the past. So maybe we are working on a second phase, a second version of the same system, and there are some lessons learned from the earlier one, that how the application worked in the past, what were the challenges, what were the issues found out, and based on that, this time when the testing is conducted, then this technique is used. Actually, these techniques are not formal techniques. So we are not documenting that, okay, these test cases are based on error guessing technique. No, it's not like that. It's just because you have prior experience of that. So you think in that way and you come across with some scenarios, some test cases that this would be, this is something where I think we should focus more. Okay, the second one is what kind of errors tend to be made. Again, how someone can know that which errors tend to be made is only possible if earlier they have seen a similar system and they know that these kind of errors were there earlier, and this time we can try to make sure that those kind of errors doesn't occur again. And the third one is failures that have occurred in other applications. Okay, so in this case, let's say that it's a new project, but the domain is the same as of the other applications which someone has worked on before, and based on that, they can recall that what were the failures last time, and which we can avoid in this new system, this new application. And so remember earlier we did some root cause analysis, which means that if we have an application, if there was a failure in production, so of course when root cause analysis is done, then we do learn some lesson, and we read that, okay, that these lessons are useful to improve the quality of the application next time. So this applies to this third line, that if we already know that last time what were the reasons due to which there were failures in the application, so this time we can avoid that, because that's the main reason of root cause analysis, to learn from the mistakes being made and to avoid them and improve the quality of the application in future. So yes, error guessing, though it's not a formal technique, but it's quite useful, quite it's quite powerful. Now, what's the approach which is used for this technique? So usually what's done is create a list of possible errors, defects, and failures, and design tests that will expose those failures and the defects that cause them. These error, defect, failure lists can be built based on experience, defect and failure data, or from common knowledge about why software fails. Okay, so now this is a kind of approach which is given, that how you can use this technique. So it can be as said that we can create a list of, we can recall that what errors were there last time, what kind of defects and failures were there, and we can create a list of that. Or if we already have a defect management, a defect tracking system, so and we are tracking all the previous defects and failures, then we can just go through those ones, and we can then create a list based on the data which we already have stored, and we can take that and compile a list that, okay, this is what happened wrong last time, and this time we can make sure that we are covering these clauses, we are covering these scenarios, or we are not repeating the same mistake. And based on that, the tests are designed. And this one is saying that, yes, it's based on the experience, yeah, it's experience of the person or the data which we already have. Mostly everyone is using the defect tracking system nowadays. So if we don't have those system, then at least we have some Excel spreadsheets in which we are storing all the execution. So let's say if there were few test cases which were failed in the last one, then this time if we have a similar scenario, then we can make sure that if something was missed in testing, we can ensure this time it's covered. And it's not only testing, it can also help us in the design phase as well, in the earlier phase as well. This is done. We are done with the error guessing. And the next one is exploratory testing. So exploratory testing, as the name suggests, it's more around exploring the system. So this is an informal tests, as it says, not predefined tests are designed, executed, logged, and evaluated dynamically during test execution. So we do exploratory testing where when we don't have any formal requirements, or we don't have any prior knowledge of the system. So let's say that as a tester, you have been assigned to test a mobile application, and you have been told that there's no documentation at all, and then what will be your next thing which you will think of? That, okay, if there is no documentation, maybe you can speak to someone who developed this, or like who wrote the specs, who worked on it earlier. But let's say that those people have left the company now, so which means that you are just left with that mobile application, and you don't have anyone who can guide you how to use it, and what was uh, how it was developed before, and can provide you no information about that, and there is nothing documented as well. So what you will do, you have no other choice than other than just try to browse through the application, and just try to explore that, okay, that how it's through the navigation, how it's responding to different inputs, different requests. So this is known as exploratory testing. And this is one scenario which I've told you. The other scenario is also that when you don't have time, and there is one resource, and that resource has been given a very limited time, and have said that you don't have time to write test cases, and you just have to do some testing in, let's say, 2 days, 3 days. So now if a tester has been given 3 days, then of course a wise tester will not spend those 3 days in writing the test cases and then executing them, because it's better that you do some exploratory testing if only 3 days are given to you, let's say, and actually you required maybe 2 weeks for that. So as a tester, you always need to, the purpose of going through all these test techniques, etc., is that whenever if whatever situation you are in, you are able to make a wise decision that what kind of testing you should do. Mostly no one will come and tell you that you should use this technique or this technique, unless of course you are working with a test lead or a test manager. Of course the test manager will guide you, but otherwise, let's say if you are the only test resource in the team, then you have the ownership of the testing, you have the ownership of quality. So no one will come to tell you that, okay, now I think this is a test technique you should use, because maybe they are not even familiar with all the test techniques. So you are the one who have to make the decision. That's why it's very important that you have a very strong base of what kind of test techniques are available. And then when you will come across different live scenarios, then you can decide that this is the time this much time I have, and to get the maximum coverage or to get the maximum quality, this is the approach I should follow. Okay, so exploratory testing, now we know that there are no predefined tests. This is also an informal testing, and it's a designed, executed, logged and evaluated dynamically during test execution. So we don't have any test preparation for that, nothing, no test data. We are just executing, and dynamically, like as we are going through the test, we are navigating to the test, we are doing our exploratory testing. The test results are used to learn more about the component or system, and to create tests for the areas that may need more testing. Okay, so the way exploratory testing is done, that we are, again, let's take the example of the mobile app, which we did earlier. So we are navigating through different menus of a mobile app, and then during our testing, we feel that now this is a specific area where you are finding lots of issues, like lots of behaviors where the app is not doing what it's supposed to do, and the user interface is quite buggy, or you are not getting the error messages which you think as a user you should be getting. So there might be one specific area where you think that there are some discrepancies, so you can focus more on that area, heavily on that area, and maybe you can ignore the other, not ignore, but like if you have just gone through like one time in that path, then you can you are satisfied that yes, that path is working, and you can focus more on this specific journey. And as it says, the test results are used to learn more about the component or system. So as you are going through the exploratory testing, you are learning as well about the system. And if you have to create tests, you can create tests from that journey as well if you have time, or you can of course just execute the testing runtime as well. Exploratory testing is sometimes conducted using session-based testing to structure the activity. Okay, so what is session-based testing? Exploratory testing, as we said, that we don't have prior test cases to that. So we are just runtime, we are going through different journeys of the system. So usually what we do, let's say that today I'm starting my exploratory testing. So what I will do, if I'm using a spreadsheet, so I will mark it as like the first session, and I will time box it that, let's say I am either doing my first session for next 1 hour, 2 hours, or maybe if there are different menus, then I can time box that, okay, that in this session I am covering only the overview section, or in this one I am just covering the withdraw section. So depending on what kind of application you are doing, so you will divide it as the session based testing, and then you can keep different files for different sessions. This is if you are doing it manually using a spreadsheet, but most of the test management tools, they also have some kind of facility to capture exploratory testing as well. Some have like the built-in interfaces in the test management system. Some of them, they have plugins, some extensions where when you are doing creating a session, it records, it captures the entire journey, the entire session you are going through, and then later on that recording can act as your test cases as well. So it depends that what kind of test management tool you are using. And if you don't have any test management tool, then as I said, you can always go for spreadsheets as well, and you can create multiple files for each session. So I hope the concept of session-based testing is clear. Of course, if there is any question, then do let me know. Right. Exploratory testing is most useful when there are few or inadequate specifications or significant time pressures on testing. So we already covered this part, that if we don't have enough requirements or specifications, or if we have significant time pressure, then exploratory testing is quite useful for that kind of scenario. Exploratory testing is also useful to complement other more formal testing techniques. Yes, so it can be combined with other formal test techniques as well. For example, if we are doing black box testing and we have all the predefined test cases, and we are running, we have executed all the test cases, and then we have different test results. So as we read over here, that in exploratory testing, the test results are used to learn more about the component or system. So maybe you already had the test cases for a system, but when you execute it, maybe there was one specific area where you found lots of bugs. And as you are more learning about the system as well, when you are executing, and then you, of course, you know about the system before as well, because that's why you wrote all the test cases. But when you are running based on the test results, you can make a guess that, okay, this is the area where I'm finding lots of issues. So maybe you can top up those test cases with some exploratory testing only in that section, because that will be useful as well. Maybe you had only certain test cases, and then if you found that this specific area is quite buggy, then you will try to dig deeper. You will do some more testing based on your runtime understanding, and that will be counted as exploratory testing combined with black box. The same goes with white box as well, so you can combine it with either of them. Exploratory testing can incorporate the use of other black box, white box, and experience-based testing. Yeah, so as we already mentioned, that we can combine it with any other test technique, either it's black box, white box, or experience-based. Like, we can combine it with error guessing as well, which we just covered earlier. So with this one, we are done with exploratory testing as well. So I hope this concept is also clear. And now this is the last concept for experience-based testing. And this one is checklist-based testing. So we did error guessing, and we did exploratory, and the last one is checklist-based testing. So in this, what happens, testers design, implement, and execute tests to cover test conditions found in a checklist. Okay, so this is a scenario where we assume that we don't have formal test cases, but all we have is maybe a list of high-level scenarios in form of a checklist. Because that can be one scenario, that there was no time to write test cases, and someone based on their experience just wrote some high-level test scenarios, that at least like something is there which you can just like check while you are testing, that this is done, this is done. Checklist-based testing is also quite popular when we are doing the deployment of when we are doing any production deployment, and then there is a checklist just to check that, okay, that is this being done, is the whatever the requirements are there, the checklist is used over there as well. But for functional and non-functional testing, it can be used as well if we don't have any formal test cases. As part of analysis, testers create a new checklist or expand an existing checklist, but testers may also use an existing checklist without modification. Okay, so if we have already a checklist, then the same checklist can be used as well without modification, or maybe we are working now on a new version of the system and we had an existing checklist, so we can take that and then we can expand it, we can top it up with some new ones, or maybe few of the earlier one or the earlier scenarios doesn't are not valid anymore, so we can modify them. So there are different scenarios which we can do, either create a new checklist or use the existing one, or modify the existing one. So it depends that what the scenario and do we have a checklist or not. Such checklist can be built based on experience, knowledge about what is important for the user, or an understanding of why and how software fails. So far, all these three test techniques, of course, these are part of experience-based test technique. So just like for error guessing and exploratory, in this as well, it's really important that whatever the checklists are being created, they are created based on prior experience and knowledge, and based on that the tester can make a guess that what is more important for user and what is the understanding of the tester based on their prior experience. Checklists can be created to support various test types, including functional and non-functional testing. So as we said that this is not confined only for system testing, so it can be used for different kind of test types and at different levels as well. So it depends that uh, in which what test type you are using. So as we went through multiple test types in non-functional testing as well, so we can have a checklist, maybe one for performance, one for usability. The same goes for functional testing as well. We can have a checklist instead of test cases. So I hope this part is clear. And in the end, the last 2 points are, in the absence of detailed test cases, checklist-based testing can provide guidelines and a degree of consistency. Okay, so we covered this already, that if we don't have test cases, then at least with the presence of checklist, we can have some kind of consistency that, okay, what we have covered, we can show that yes, this is what we covered, because we can have a checklist and then we can just tick that yes, we have tested this, we have tested this. So at least there is some evidence to show that what kind of testing you have done, and it can provide some guidelines and also some consistency as well, that yes, you have consistently tested these areas throughout the system. As these are high-level lists, some variability in the actual testing is likely to occur, resulting in potentially greater coverage but less repeatability. Okay, so as these are, okay, one way is that we don't have any checklist, we are just randomly going through the system, which we said exploratory testing. So in that, because we don't have anything documented, it's quite likely that maybe we are repeating the same number of tests, maybe we are going through the same journey again and again. But over here, because we have some checklist, so we have something in front of us that yes, oh, I already covered this area, fine, I don't have to cover this one. So it's more likely that the testing which you are doing is not repeating a lot. And when we are not repeating the testing, it also then ensures that we are maximizing the test coverage as well. So this is all about the experience-based testing, and with that, now we have completed our module of test techniques. Next week we will start a new module, which is test management. So with this session, do you have any question before we move on to our practice questions? Okay, no questions. Let's move on to our practice questions then. Right, the first one is, given the following sample of pseudocode, I already told you what is pseudocode. So we have these number of statements. So these are just the numbers and these are the statements. So it says input number of sandwich, input number of iced tea. If sandwich is greater than 0 and iced tea is greater than 0, then input, do you want home delivery, yes or no? If home delivery is no, print serve their order now, and if, and if. So we have one and if for this if, and we have one and if for this one, right? So which of the following test cases will ensure that statement 6 is executed? This is the statement 6. So can you please try to do this, and then let's see that which answer you come up with. Okay, I have already got an answer from Vineet. Let's wait for a few more and then we can go through. So Jatin, UV has also given me an answer. Madhuri, Gaurav. Okay, all of you, you have given me the answer B, which is absolutely correct. So that's really, really good that you have understood the concept. You're all, maybe were already familiar with it, because usually this can be confusing, but I'm quite happy that all of you are clear of this concept and you have opted for the right option. So I don't think that I need to go into detail and try to explain that why B is the correct answer. If anyone is not clear, please let me know. We can go through this in detail, but based on all the answers you have given to me, I think the concept is already clear. So yes, B is the right option. Sandwich 1, if sandwich is 1, which is greater than 1, iced tea is greater than 1, and home delivery is no, then this will be executed. If this is yes, then of course it will not be executed. Okay, so that's really good. Number 2 is, if all the statements of code are executed, that means every decision is executed at least once. True or false? So what do you think? Is it true or false? Okay, I've got an answer from Madhuri, Gaurav, and Vineet. And all of you have answered true. Sorry, Madhuri is saying false, Vineet is saying true, Gaurav is saying true, and Madhuri, you are correct. It's false, it's not true. Let's see how. It's saying, if all the statements of code are executed, that means every decision is executed at least once. So remember, we covered that 100% statement coverage does not guarantee 100% decision coverage. It's the other way around. So over here, it's saying that if all the statements of code are executed, statements means only the executable statements. And remember, we spoke about that in statement testing, we only cover the true conditions, not the false ones. So that will cover only half of the decisions, not the remaining ones. So if it was the other way around, then we could say that it's true, but in this case, it's false. Yes, Jatin, you are right. 100% statement is not covering 100% decision. That's correct. Okay, so yes, it can be confusing, but these kind of questions does come in the paper. So just make sure that you are reading the question at least twice. That is it asking about statements, then cover decision or statements. One another thing, as the decision testing is the same as condition as well. So sometimes maybe instead of decision, the term condition is used. So please make sure that you are not confused that, oh, we haven't done condition testing. So it's the same, decision and condition is the same thing. Okay, moving on to the last one. How many test cases are required for 100% statement coverage? So over here, now we are talking about statement. So we have this code, read A, read B. If A is greater than B, then X is equal to 0, and if. Okay, I've got an answer from Jatin, Yuvi, Vineet. And all of you have answered option A. Madhuri has also given the same option. Okay, so that's the correct one. So the first one, which is one test case. So one test case is required, minimum one test case is required for 100% statement coverage, because it will go through all the statements over here, and that would be sufficient. Okay, so with that, then we come to the end of our today's session. And just a couple of things which I wanted to mention regarding the topics which we covered today. So white box testing, especially white box testing, this is the part where there have been some changes as compared to the earlier syllabus. So sometimes, let's say if you are going through internet and you are trying to practice few questions, then just make sure that are those the updated syllabus ones or not, because there might be some old ones which are not in the syllabus anymore. So I just don't want you to be confused. So this is one thing, that this is an area where there are few updates as compared to the earlier syllabus. Not a lot, but maybe slightly. And of course, if you have any confusion and if there is any question you come across and you are not clear, then yeah, please let me know. Or you can always go to the updated syllabus 2018, which is currently based on which you will be tested. So you can always go through the syllabus PDF file as well, or you can ask me. I will definitely let you know. One another thing which I have seen at most places on internet, that sometimes decision and branch, these two terms are used interchangeably, like branch coverage where you are covering all the branches, or decision coverage. Many places I have read that it's written decision or branch. I just want to clarify that don't make yourself confused with these terms. Branch coverage is closely related to decision coverage. We can say that branch coverage is similar to decision coverage, but it's not the same. There is a difference. And I was quite surprised to see that few places I saw that it's written decision or branch coverage, which is absolutely wrong. Whenever you are reading anything on internet, always try to verify it, maybe from a book, which of course is validated. It's more reliable, because even like if I'm telling you something, maybe my concept is not clear, and if there is a doubt, it's always good to just check with someone. But just wanted to make to clear this concept that branch coverage is similar to decision coverage. And just like we said that 100% decision coverage covers all the 100% statement coverage, we can put branch coverage at the top of decision coverage. So we can say that 100% branch coverage guarantees 100% decision coverage, and decision coverage and guarantees 100% statement coverage. Because what's the difference? There's a very minimal difference. So decision coverage measures the coverage of decision, like all the conditional branches, and while the branch coverage, it measures the coverage of both conditional and unconditional branches as well. This is not part of the syllabus, but I just wanted to ensure that you are familiar with this term as well. And if you see this term anywhere, you understand the difference between branch and decision. So decision, we already know that whenever in the flow diagram we see that diamond structure, diamond image, that is the decision, that what is the there's a condition, there's a decision, and there is a decision outcome. While the branch is that in the controlled in a flow diagram, when we see, like, let's say a start section and end section, from start to end, that entire flow is a branch. So there can be multiple branches. So now you can understand that the concept of branch is more, the coverage of branch is more than the decision. If it's not clear, do let me know and I will try to clarify it further. But just wanted to make sure that you are familiar with the differences of these concepts. So this is all from my side for this session. Do you have any question? Okay, no more questions. So in next session, we will start our new module, which is test management, quite interesting. And we will go through different scenarios. So that would be quite exciting. And as usual, I will upload the recording of this session lately today, sometime later today. And I will also upload the slides as well in our Facebook group. And I will see you then next week. If you have any question, then please just feel free to ask me. Till then, take care of yourself, and I'll see you next week. Bye.